Right, here we're looking at section 3.2, and in this section we're really dealing with some complex numbers. So we're going to be looking at some subsets and really what are complex numbers. So our learning targets for today, first we're going to define and use the imaginary unit, which is I. We've been dealing with only real numbers so far, but now we're going to throw in some imaginary numbers, and that's where we denote with this I. Then we're going to add, subtract, and multiply those complex numbers, because we have to be able to use them. And then we're going to find some complex solutions. So again, we're looking at our quadratics and finding solutions in zeros. We've been looking at real solutions. Now we're going to be looking at those complex solutions. So the first thing, how do we get I? So I is when I take the square root of a negative number. Okay, so when I take the square root of that negative number, I can pull out my I, which is my imaginary number unit, and now have the square root of that positive value. So then I can simplify from there. So I also know that if I'm squaring I, so if I have I squared becomes a -1. That's really important to remember when we're simplifying and solving later on, that I squared equals a -1. So if I see something like this, right, I can take this, since I'm multiplying, and distribute that squared. So I end up with I squared times the square root of 3 squared, which is 3. So I end up with a -3. Big thing here, I squared equals -1. So find the square root of each number. So first I see I'm taking the square root of a negative, so I'm going to go ahead and pull out that imaginary number, and now I have the square root of 25. Well, I know what the square root of 25 is, so I've got 5i. Alright, so now let's look at part B here. So again, I'm taking the square root of a negative, so in order to get rid of that, I'm going to pull out my I, my imaginary number, and now I have the square root of 72. So now I need to simplify this radical, so let's break it down into its pieces. Okay, so my I we're just going to leave there for now, we'll come back to it. So I know that 72 is also 9 times 8, and I can break these down, 3 times 3 and 4 times 2, and that 4 can still be broken down into 2 times 2. So now I'm going to go ahead and circle my pairs that I have in order to fully simplify. So now I still have that I times, since this was a pair, this comes out as a 3, and I had a pair of 2's, and then I still had a square root of 2 left inside. Okay, so now let's simplify. Well, I know 3 times 2 is 6. That I is still out front times the square root of 2. And this is the standard way that we write these numbers with imaginaries. So my number comes first, then my imaginary number, then any roots or radicals that we have later on. Okay, so now that's fully simplified. So I found that square root. So now let's look at this one. So I have a -5 outside times the square root of a -9. So I just continue to simplify. We're going to leave this -5 alone for now. I see I have the square root of a negative number, so I take the I, and this becomes the square root of 9. Well, I know the square root of 9 is 3, so I have a -5 times I times this 3, so I have a -15i, is how I can fully simplify this one. So now here are a few for you to try. Make sure that you can actually simplify the radicals even if you don't know what the square root is. So now we're going to look at some complex numbers. So a complex number is where we have a plus bi. So I always have my real part first and then my imaginary part. And now let's look at what we do with these. So here we have some values, and we have to find what x and y equal that satisfy this equation. So what I really want to do is I want to set the real parts equal to each other and the imaginary parts equal together. So I set the real parts, right? My real parts are the part without the I. I set those equal together, and then I set my imaginary parts together. So here's my real parts, and I solve for that variable, and my imaginary parts, and I solve for the y. So x equals 5 and y is -7. So it's really simple if you can just think of this as a real piece and the imaginary piece, and then set them where they need to go. So here are some for you to try, like we just did. Remember, I've got some real parts, and then I've got some imaginary parts. Set them equal to each other, and then go from there. Okay. So now we're going to actually add and subtract these complex numbers. We're already on to that second learning target. Okay. So we want to break our real parts and our imaginary parts into pieces. So here I have a plus bi plus c plus di. So I see that my a and c are my real parts, so I go and I add them together. So I see that b and d are my imaginary parts, so I add them together, and then I also include this I at the very end. So same thing when I'm subtracting. I take my a minus c, and then my b minus d. So let's look at some examples. Okay, so I have this 8 minus I plus 5 plus 4i. So my real parts are this 8 and 5. So I have my 8 plus 5, plus, since I was adding, my imaginary parts. Here's a negative 1 plus 4, and then my I is included. So my 8 plus 5 is 13 plus 3I. Okay? So now let's look at the second example. Now I'm subtracting. So here I'm going to deal with my real parts. So 7 minus 3. And then I've got a negative 6 minus 6. And I can't forget my I there. And this is always going to be a plus sign in between because I've distributed this negative sign already. So I know I can add this. So 7 minus 3 is 4, plus negative 6 minus 6 is negative 12i. So now let's look at part C. Part C is a little bit more complicated, but I can go ahead and group parts in C first. So now let's deal with this. So here I have my two real parts, so 13 minus 2. So I have 11 plus 7i plus 5i. Well, so now I want to go ahead and group the imaginary parts together. So I'm going to have 11 plus 12i. So again, we're just grouping the pieces that are similar to simplify. Okay. So here we can have some of our real-world problems. So we have some electrical circuit components, right, such as resistors, inductors, and capacitors, all oppose the flow of current. This opposition is called resistance for resistors and reactance for inductors and capacitors. Each of these is measured in ohms. And we use this omega, this capital omega, to show that. Okay, so now here we've got our little table of what we're looking at and our picture. So this table shows the relationship between a component's resistance or reactance and its contribution to impedance. This is the, right, it slows it down. That's what we're talking about. It opposes the flow of current, so it slows it down. That's what impedance is. So a series circuit, which we have here, is also shown with the resistance or reactance of each component labeled. So the impedance is the sum, so there's a math word that I know we're going to need to use here, so I'm adding, of the impedances for the individual components. So find the impedance of the circuit. Okay, so let's look at what we have here. Let's look at here. So here I see I have an inductor, and I know that it's an inductor because it's a coil. So I know that it's going to be just Li. So I see I have 3 ohms, so this is going to be 3I. So continuing on, I see I have here a resistor with 5 ohms. So I can go ahead and place that. My impedance is just R there, so plus 5. And then as we continue, I have a capacitor with 4 ohms, and I see I have a negative Ci. So my C would be 4, and my I there. Well, so now I'm adding these all together so I can find my common terms and simplify. I see I only have one real value, so I do that first. And then I have 3 minus 4i minus I. So the impedance of my entire circuit is 5 minus I. So again, we're just looking at real pieces and the imaginary pieces and looking at them separately. Okay, so now we're going to be dealing with multiplying. So remember back at the beginning when we talked about learning targets that I squared equals a negative 1. That's really important to remember here. So let's just go ahead and multiply. So again, I see I have something outside the parentheses, so I distribute to everything inside. So 4 times negative 6 is negative 24i. 4i times I is a positive 4i squared. Well, here's an I squared, so let's simplify. So negative 24i plus 4 times that negative 1. Well, this turns this into a negative 24i minus 4. I don't want to leave this in this form. I want to write it back in my standard form, where my real part is first, and then my imaginary part is second. Okay, so now let's look at part B. We're going to do part B very similar to what we did. So here I have two binomials, right? They both have two pieces. So I take the first one, so my 9 times a negative 4 plus 7i minus 2i times negative 4 plus 7i. All I'm doing is distributing these to both of my terms in my second binomial. So a 9 times negative 4 is negative 36. 9 times 7i is I now have my I value included, is my 63i. Negative 2 times negative 4 is plus 8i. Negative 2 times 7 is 14. I times I is I squared. So now let's kind of simplify what we have. This negative 36 will stay there. Here I have some common terms. They both have i's, so 63 plus 8 gives me 71i. And here I have this negative 14, but I have to multiply it by that negative 1 because I squared is a negative 1. So I have negative 36 plus 71i plus 14. Well, now I see I have two more terms that I can simplify, so I end up with a negative 22 plus 71i. And I look and make sure that I'm in the correct form where I have my real part first, which I do here. So I can go ahead and move on. Okay. So now here are some for you to try. Make sure that you can add and subtract all of these together. That's really what we're looking at in these word problems. And that you understand what we're doing when we're multiplying. Okay. So now here's this third learning target where we're solving some quadratics. And here I want to see in both of these, I see I do not have an x term, so I'm going to use the square root method. Okay, so I have x squared plus 4 equals 0. Well, I know I have to get my x squared by itself, so I subtract 4. So x squared equals negative 4. Now let's take the square root, and when I take the square root, I have plus and minus the square root of negative 4. Well, here I have a negative, so I'm going to, oops, that's not squared anymore, equals plus or minus I times the square root of 4. So I pull out that negative with my I. Well, I know what the square root of 4 is, so my final answer would be plus or minus 2i, because 2 is the square root of 4. So now let's look at part B. So I have 2x squared minus 11 equals negative 47. So step 1, I'm trying to get this x by itself, so I'm going to add 11 to both sides. So 2x squared equals negative 36. So now to get x by itself, I divide by 2. So I end up with x squared equals, and this is going to be a negative number because I'm dividing a negative by a positive. 2 goes into 3 one time, there's 1 left over, 18. So now we're going to square root both sides. So I have x equals, and when I square root, plus or minus the square root of a negative 18. So when I have this negative, I go ahead and I pull out my I. So I have plus or minus I times the square root of 18. So let's go ahead and simplify this square root of 18 if we can. Okay, so we want to find its prime factorization. So I have 9 times 2, but I know that 9 can also be 3 times 3. Well, since I have a pair of 3's, I'm going to pull that out. So I've got plus or minus 3i times the square root of 2. And that's as simple as I can get that answer. Okay, so those are my two solutions. And we went ahead and looked at this quadratic. And so now I have my positive 3i times the square root of 2 and my negative 3i times the square root of 2. So now we're just going to find the zeros of this one, very similar to what we just did. So when I'm finding the zeros, I know that I'm finding those intercepts where my y equals 0. So I can set that up. 0 equals 4x squared plus 20. So we need to get this x squared by itself, so we subtract 20. So negative 20 equals 4x squared. Well, to get this by itself, it's multiplying, so to undo, I divide. So negative 5 equals x squared. So to undo the squaring, I take the square root. So I have a plus or minus. We always have to have that included of a negative 5 equals my x. Well, now I have this negative, and I don't want to leave this inside my radical. So I can pull out my I times the square root of 5 equals x. So these are the two roots, the imaginary roots of my quadratic. So now here are a few more for you to try and see how you can do with these. So now let's look back at our learning targets, see how we did for today. First, we used our imaginary unit I, and we know that I is when I take the square root of a negative number. Then we added, subtracted, and multiplied those complex numbers. Then we looked at some complex solutions and zeros of our quadratics. So now that we've worked through all this, go ahead and work on your homework for this section.